Yeah.
Yes,
Okay,
sir.
so once we can have a meeting in video mode, right? Not today. Once we can have a meeting. So how many people have joined?
The 33, sir, half the people.
Half of the people, right? Shall we wait?
There's just 2 more minutes, sir. Then
Okay.
I drop the message for
Yeah,
people
yeah.
as soon as possible.
Did you have a class before this?
No,
No,
sir.
sir. No, sir.
Okay, so you could have informed me. I was free. So I've sent you certain files in this classroom. Did you check?
Uh, no, sir.
Is my screen visible?
Yes, I just saw
Yes,
there
sir.
are many
Yeah.
files.
Not many files. I have given you certain files that I want you to go through, and mostly it is concerned with the assembler directives of the assembly codes for Intel architecture, right? So I put both 32 and 64-bit architectures. I have put assembly.pdf file. I have given architecture software developers manual for Intel 32 and 64. And I've given a book, Introduction to 64-bit Intel Assembly. Just observe my cursor. Can you see?
Yes, sir.
Yes, sir.
Yeah. So you have to go through all these books, and before you go, there is a ODT file. You click that file, and I have given certain links. For example, slides of Dr. M.A. Karkare. He is Associate Professor, Computer Science Department, IIT Kanpur. So in fact, I was going through certain teaching slides, right? For example, I was going through MIT OCW teaching slides, Ullman's teaching slides, and I found that for compilers, people are following different architectures, right? So mainly in the US, in the West, if you go, you will find people writing books on the Spark architecture, right? So that is not going to help because most of us have Intel architecture machines. Am I right?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So yeah, so using those slides will not be wise. So what I did was I was going through slides because there is no point in reinvention of the wheel. It's a wastage of time because I didn't get any time to build slides because I am not habituated to teach with slides, right? I'm more comfortable with board work. So I found certain slides from Dr. Ame Karkare, and it is available in his GitHub link. I've provided the link. If you click in that link, you will find his slides, right? And I will follow some slides, but mostly the reason that I have ported to Linux in this semester is that I want to show you something of a more practical nature, right? And to start assembly, um, I have provided two very good links of the GNU assembler, the syntax of the GNU assembler. It is called GAS. GNU AS stands for assembler, right? GNU assembler syntax. That means you will get to know the exact exact naming convention of the registers, and you will get to know the naming conventions of the instructions, assembly instructions. Those are called mnemonics, right? So I hope you remember something from your old semesters. Now, by the way, you studied assembly in the offline mode or in this online mode in the past semesters?
Online, sir.
So online.
Oh, assembly also you had the online course.
Yes, sir. It was a few classes also, not much. We had to do the computer architecture lab in assembly. So some
Was there a full-fledged paper on assembly?
No, sir.
no, sir, and that was not some teaching assistant took it, sir, not a professor also.
So that is very bad. I am very sorry to say that that is very bad. You should be having at least a course on assembly as you are having a course on binary, right? Your digital logic in first year. So you should be having a course on assembly. That is extremely important. You should be having a course on system software. That means assemblers, linkers, and loaders. Did you have a course on system software? I hope no.
No, sir.
No, sir.
No, sir.
So that is very bad. So okay, it is better late than never. I have provided you with some very good links, right? For example, let me click this link and I will show you where it goes. Okay, it's not clickable right here. You can just copy and paste it there in your browser. So it's wikibooks.org wiki 8686 assembly. It is GA stands for GNU assembler, right? And GNU assembler syntax for the x86 architecture. These two documents, right? And here you can go and find the slides of Dr. Karkare. Okay, so I will not follow his slides exactly, but I will take help of some of his slides because that would save some of my time. Okay, so shall I start?
Sir, I had a doubt, sir, about Dr. Karkare's slide, sir.
Yeah, did you click there?
Sir, yes, sir. Yes, sir. I actually downloaded a couple of the slides, sir. Sir, I also saw that there was a manual, sir. I'm not sure what it was on, but it was authored by Dr. Shomo Debroy, sir.
Yeah,
Sir,
that
do
was
we
that
need to
that is no. In due time I will inform everything, right? So that is a
Okay.
that is a document on lex. So for lex it is not extremely important to go through the document of Shomo. So for lex you have thousands of documents on the internet, right, in the open source domain. In due time I will tell you, right? Okay,
Okay,
so
sir.
lex is a platform that generates your lexical analyzer automatically, but we have not gone through all those things, so better not to talk about all those things. So today I will, for example, I have opened the terminal. So this is the introductory a slide of Dr. Karkare. So so I have put it in the journal file system, journal system, so that I can put some annotations also. So this is the book that you are supposed to follow, and let us quickly go through these slides. I request you to go through these slides at home, right? Do you agree?
Yes, sir.
Yes,
Yes, sir.
Yeah, yeah. For example, if you go through this slide, if you go through this slide at this point, let me take out my Wacom. Yeah, I have configured the Wacom just for you guys, right? So I expect that you will be supporting me and you will be attending my classes, and you will be at least having some expertise. You are studying computer science, so you have to justify, right? So you cannot say that I do not know much about automata, I do not know much about compilers, operating systems, assembly. These are the basics you need to know. Okay, so this portion, can you see? I'm marking with my Wacom. This portion,
Yes, sir.
yeah, this is the heart of what you know, the main motivation behind studying a large number of system software. That is why I was asking whether you studied system software or not. Now, system software is a course of study that teaches you about compilers a bit, not so much of details that we are going to do in this class. Compilers, assemblers, linkers, and loaders. And what I find is you don't have any concept on these, right? And
sir,
you
we
are in
have
fifth.
a OS course and database course this semester.
Okay, but you are in fifth semester, Abhishek, right?
Yes, sir.
So system software is a very important course, right? It talks about compilers, it talks about assemblers, it talks about linkers, it talks about loaders. So you are students of computer science, and the main job you are going to do is you have to have a clear perception of programming, right? You have to have a clear perception of what happens when you compile your program, what happens when you test your program, what happens when you run your program. So a large number of system software and application programs require structured input. This is the main motivation, right? So we need to provide inputs to all these systems: compilers, assemblers, linkers, loaders, operating systems, databases, LaTeX. How many of you are aware of LaTeX? It is a text formatting system.
Yes, sir.
Now those of you would like to pursue higher education, you have to write your papers and thesis with LaTeX, right?
Yes, sir.
That's the standard. So all these systems require some structured input. This is most important. And whatever we do, we pursue for structuring the input to that system, because we are in a formal domain. We are talking about a formal system. We are talking about a computer, right? So a computer doesn't have the non-determinism of your brain. Go to the previous semester. So non-determinism, I talked about non-determinism, right? Although in a theoretical way. So what I meant was humans have the power of thinking many things together. Computers doesn't have that power. So you need to provide inputs in a very structured manner as a main motivation. Okay, so wherever input has a structure, we can think of a language processing system. And compilers use the whole spectrum of language processing technology. So immediately you have something called language processors. So compilers are a classic example of language processors, right? So why? Let me quickly go through all these things, because I have talked about all these things. I want to go to that picture. So this is a picture. You write a program, right? You write a program in your editor, and a source program is born, and that source program is fed to your compiler. Now in this semester we are going to study these aspects, what the compiler is supposed to do and how it does. Two things: what the compiler is supposed to do and how it does that, right? These two things. There maybe I can define right now, I can define 50 more subsections of these 2 points, but that is not necessary. Now the compiler compiles the source program. So what was the name of the program that we wrote in the last class?
So testprogram.c.
Yeah, testprog.c. You input it to the testprog.c, and you input that program to your compiler. We use GCC, right? And actually this GCC was calling a program called CC1, right? Do you remember? That was the compiler, the main compiler, because GCC is a compiler collection system, right? So I would go through that code again, don't worry. And the output is an assembly code. The output was testprogram.s. Did I show you how S looks like?
Yes, sir.
And that assembly code was taken by, what happened here? Did I change the slide? Okay. That assembly, so it was testprogram.c, and here the output was testprogram.s. This .s file, the assembly file, was taken as input by the assembler, and the assembler will output the machine code, that is testprogram.o, right? And that machine code will be linked with other codes, other machine codes. So you have testprogram.o, testprogram.s, testprogram.c, and here the linker links your testprogram.o the machine code of this source code via this assembly code you have it at your hands. The linker links other system-wide objects with test program.o, right? That is the work of the linker. Other system-wide objects, right? Why it is done? Because you have to the linker performs three specific jobs. What it does is relocation of object code, and it resolves references to variables in other object files. That includes library files also. Now, did you hear about something called DLL files in Windows? I hope everybody will say yes, because everybody loves to play computer games, right?
Yes, sir.
Yes? Yeah. So what is DLL? Dynamically linked library, right? So there are libraries are of two types. One is statically linked and one is dynamically linked. Statically linked means your .h files, those are libraries, and those libraries are already taken care of by your compiler. A copy of that .h is appended to your .c file, and then the process starts like this, right? And dynamic libraries are already some .o files. Those .o files will be linked with your program so that your program can access the service of those .o files, those dynamic objects. Now, Linux uses a extension called .so, called shared objects. Those are the DLL equivalent of Windows. Windows has DLLs and Linux has .so files. So linker connects your code to other object codes such that if your code refers to some portion of code that was not possible for the assembler to address. For example, your .o file looks for the output of some function that resides in some other objects, right? So the linker plays a very important role in linking your object with all these objects, system-wide objects, right? And it resolves all such issues, and you have your machine code, right? So you have your machine code. Now your machine code is loaded by the loader. Loader is a piece of system software. It loads the machine code for execution in your target machine, right? So executable image. So if I name now, finally if I name it, it was test program.c, then assembly was test program.s, machine code was test program.o, then this was these two taken together gave you test program, the executable, right? So if I go back to my terminal, where is my terminal? If I go back to my terminal, I hope I had all the files here, right? So test program.c, is it visible? Everybody can see?
Yes, sir.
Yeah. Okay. So I have here test program.c. You started with test program.c, and I showed some extra strip that is not being shown in the slides, right? It was test program.i. That means the output of the preprocessor. So you can think of so in this, so what I had shown you is a preprocessor plus the compiler, right? So test program.c was input to the preprocessor outputs test program.i, that is taken by the real compiler, and then the compiler outputs this assembly. That is what I had shown you, right? Do you remember?
Yes,
Okay.
Yes,
sir.
sir.
Sir, test
Yeah.
of that I
Yeah.
is that after finding the statically linked library files.
No. I'm telling you. Yeah, you are partially right. So test program. So it was test program.c. You started with that. Then you called the preprocessor and the out processor, and the output was test program dot I, that is the preprocessed output. Then you call the real compiler. The output was test program dot s. Then you call the assembler as, and the output was test program dot o. Then I combined the linker and the loader both to give birth to test program, actual executable. Now actually this is a very interesting question. What is test program.i? This is called the pre-processed input being pre-processed, right? Being pre-processed. So this .c file has many hash includes, right? So in that way, whoever told that does it take care of the static headers? Yes, right? So it has hash includes, it has hash depths defines, and it even has if depths, right? Whatever it has, the preprocessor resolves all these things. So if you are talking about .h files, that means static libraries, the preprocessor helps the overall compiling system in expanding that .h file and appending that .h file at the end of the .c file, right? Such that all the references and all the functions that are defined in this .h file is a local part of this program, right? The program size increases, nothing else happens, right? And it resolves the hash defines, that means the macros, if depths, all these things are taken care of by the preprocessor, and the output is test program.i. Now test program.i is the preprocessed output, that means test program.c was referring to certain functions that were defined in some .h files. Now those function definitions were appended to this program. So what will happen? Those functions become local to this program, right? So test program.c has all static references resolved. Did you get my point? It has all macros resolved. That means in our program we used a macro pi, right? Now this test program.i contains code that says that whenever you see a pi, you blindly replace that with 3.141. It has the code that does that. Now this is the input to the real compiler. So actually preprocessor helps the compiler in resolving all such issues, includes, defines, if depths, right? And in this slide actually this preprocessor is not shown. What is shown is you have the input, and then you have the compiler, then you have the assembly as output .as. Generically it's called .as. In Linux we call it .s, done. And then it is taken care of by the assembler, and you have the .o, and then taken care of by the linker and loader, and you have the executable. Any question?
No, sir.
Okay, done. So
Sir, can you
this,
explain about the linker and loader?
yeah, I will explain. Okay, I will explain. For now you have to think. Okay, so let me give an example. Actually, I was trying to avoid wasting so much of time there. Okay, I will explain. Any questions asked to a teacher needs to be explained, right? Okay, so I will explain with a diagram. For example, you write a program called 1.c, and what you do is you define some extern variable, extern int a b, right? And in some program 2.c, you use this AB that has been defined in 1.c in your own function. You are now 2.c, add AB, and you have written a function like this: return A plus B. Did you ever write some programs like this?
Yes, sir.
That a function, yeah, a function is defined in 2.c, a different program, but that program intends to use variables that are defined in 1.c. That's why since in 1.c A and B are intended to be used by some different program, that is 2.c, it was defined as extern. Did you write some programs like this? Immediately take an assignment to write some program like this. Or I have already written the program, but you have to write it complete, right? So what will happen? Yes, what happened? Yes, somebody watching serials and soaps. Hello? Am I audible?
Yes, sir, you're audible.
Okay.
Yes, sir.
Yeah. Okay. So if you have two programs like this, and if you independently compile with GCC -o 1.c, you compile this program independently, and you compile this program independently, GCC-o 2.c. So immediately you have 1.o as the object file for this 1.c, and you have 2.o for the object file of 2.c, right? Yes or no?
Yes, sir.
Yes, sir.
Now what to do? Now you have to call your linker and request him to link these two files. Otherwise you cannot run, because these are connected programs. Now you should be calling your linker, and in Linux it is a program called collect2. There is a program called LD also, it's the loader. You need to call collect2 and LD one after another and ask them to link these two .o files and to form a composite .o file, say 3.o, and then you finally call GCC 3.o, and it would give you the output is 3. 3 is the name of the program that is supposed to run. Did you understand what I was intending to say? Yes or no?
Yes,
Yes?
sir.
Yes. Everybody?
Yes, sir.
Yes,
Yeah.
sir.
So somebody asked the question. Is it clear to him?
Yes, sir. Yes.
Yeah. So now what I mean is, so this was just a simple example that just came to my mind, and I gave that example out of my experience. But really what happens is, in your program your test program dot o, right? Test program dot o. Okay, let us see the output. Things will become clear. Okay, vi test program dot o. I'm sorry, I'm very sorry. We need to have that output of GCC, right? So GCC -save -temps, go in verbose mode, and then compile test prog test prog dot c. Do you remember this? Okay. Now let us go to this section. So here, see, here, this is the path of the program CC1. It's the compiler. This is where GCC calls the real compiler. So CC1 is your compiler. You can take a note. CC1 is your compiler. So since you are working with Linux, you can even go and download the source tree of CC1 to inspect how the compiler works. It's the whole compiler, CC1. Remember, by compiler I mean it takes .c as input and it gives .s as output, right? So the main function of the main component of the compiler is it takes a high level language and forms an assembly for your architecture. Got my point? Okay. So CC is called, this is the compiler, and it takes input your .c file as input and outputs testprogram.i. Done in the first instance. And then again this compiler is called, that takes as input the preprocessed code -f preprocessed. What is that preprocessed code? Testprogram.i, and it produces testprogram.s. So this is the invocation of the compiler again by GCC. So this time the compiler was called just to do pre-processing and producing testprogram.i. Here the compiler is again called by passing the pre-processed code testprogram.i, and it gives you testprogram.s. The job of the compiler is now over. Done. Now the assembler is called, this is the invocation of the assembler. So AS is the assembler program, right? Yes or no?
Yes, sir.
Yeah, so AS is the assembler program and it takes as input testprogram.s and it builds testprogram.o. Right? Okay. Now let me come to the question that was raised. So here what is being done is, see, library path. Let me just keep my Wacom away so that I have access to the keyboard. So you have library path, right? What is library paths are being resolved for finding out static libraries and dynamic libraries, right? And that is the main job of the linker. So there are, you find library path, you observe, take your time and observe. So these are the paths where libraries are to be looked for. Basic paths: user lib gcc x86_64 linux gnu 9. This is one path, right, where you can find libraries. What are libraries? They can be both static libraries and dynamic libraries. These are paths. User lib gcc, it has certain libraries. Now user lib gcc ... gnu, this is another path. Paths are separated by colons. Now this is another path. It starts here. Sorry, it starts here, right? And it goes here. Now this is another path. So library underscore path, this directive tells the compiler system GCC. Please note that I am talking about compiler system GCC, that okay, look for libraries in these paths. This is, for example, another path. This is another path. This is another path. And I hope if you work with Linux, you know that user lib is always a path, right? So these are paths. Now, so the compiler system tells the compiler system that these are the paths to look for libraries, right? Done. Okay. Now you call the program called collect2, that is the linker, and you talk about certain libraries. See, I have here, I can see some plugin.so. It's a dynamic library. It's called shared object. Got my point? And you can see there are certain options called -l. Now each of these -l flags specifies a directory to look for needed binaries. So it says that you should look for some needed binaries in this directory. You will find certain libraries here. This one again -l, and then it says that okay, you can look for libraries, certain libraries in this directory. Done. Again there is another -l. It says that okay, look for libraries in this directory. Okay, and what is the name of those libraries? It is specified. Also you can see some okay, so what exactly is done is it will, this linker will link all these .so files .o. See, there is a some crt1.o file. That is what I meant by system wide objects. So this is a system object file. If you don't link your object testprogram.o with this, your program running environment will not be created. Got my point? It may be a library for your display. Got my point? So there is another library like this .so. It talks about some plugin. So if that plugin is missing, you do not know what will happen when you run your program. Maybe you cannot input your input some text. So to understand what exactly these plugins do, you have to do a thorough research, a whole 1 year research on linkers. That is not possible. So it is better to use GCC to call the linker. See, what is the command that we passed to just compile? We gave GCC -save-temps so that we have this testprogram.i.o.s temporary saving temporary states, varvos, so that I can see what is going on, compilation, testproc.c. And so all these things that you can see are being taken care of by GCC only, right? That's why you need a compiler. It's never possible for you to understand, okay, what are the .o files that I need to statically bind or dynamically bind with my .o. So this linker, that means this collect2 program, will link all such libraries. This is one such library, .so. Let me find the libraries for you. Okay, so here you have .so.2. This is another library, and this is one .o file. So similarly, this is one .o file. There are many such .o files that the linker links with your testprogram.o. So this is your testprogram.o, right? So with testprogram.o, it links many system-wide functions. For example, printf uses your system's display buffer, right? It's a file called standard output. So printf uses that output device. So there must be some .o file associated with that operation. That if you can do research on that, you can find that okay, maybe scrt1.o is that object that is responsible for that for calling of those display drivers. Now is it clear what the linker does? It links. This is the linker program. This is the whole path. User leave gcc x86 linux gnu/9 collect2. Collect2 is the program. For example, if you go here, if I just copy and go here, cd, if I do ls, you will find collect2 in green, right? So if I do ls-l of collect2, you will find that it's an executable file. Do you see the access? It's an executable file, and this is your linker program. Who calls the linker program? GCC calls the linker program, so that you don't have a headache. Now in course of this whole compilation, that means in course of formation of the the assembly code, and then the object code, and then linking of that object code. Now to find out what exact symbols your testprogram.o needs, you can use a command called nm testprogram.o. and it gives you that, okay, these are the symbols that needs to be resolved, right? So if you want to find out where these symbols, so these are the symbols, right, that needs to be what it is called, resolved. Now you can see there is a main, right? What is this main? Actually, this main is the symbol corresponding to your main function. And as you know, when a program runs, your main the address of your main should be first taken care of, right? And then the program execution starts. And all these U's means undefined. So for printf in your test program.o, there is a symbol called printf that is still undefined, and that is why you need to link with system wide objects. This is your test program.o, and that is being linked with system wide objects. There are many such objects. U means undefined. Yes. Now, if you want to see that, okay, what exact library is responsible for the correct functionality of printf, you can give a command like let us go to uh, user lib, right? That's the best area to find out libraries. Okay, there are many libraries here, so I have to write a command so that it goes through all these. So you can let me do a man nm. So I give you an assignment to find out what exact libraries libraries like .sl, .so, .o, what exact libraries are responsible for the correct functioning of printf. It can be found out by listing of symbols from object files, and then the object files may be tracked back to the libraries that have them, right? So I give you an assignment. Take down the assignment to go through the manual page of this nm command that lists the symbols of object files, and provide the right options to find out what exact libraries are required by printf. Because here I see okay, sorry, I have to go back. Here I see that printf is yet undefined in test program.o, so I need to link it with other object files across the system. So if you want to find out what exact library, it should be it should be always here in this case. See, you have generated test program.o, you have already done the statically linked cases you have taken care of. So in spite of that fact, since printf directly interacts with your display drivers, directly interacts with your operating system, it manages the output buffers, and it displays it displays characters, it displays integers. So you need to have that support, right? So what I mean is, use nm. The assignment goes like this: use nm and provide appropriate options to this command nm, and find out what libraries contain the required objects, the object files required for printf to function properly. Yes. Okay. And you can do a man page read down of the nm command like this. You can use this command because I give you an example of the extern family of system functions. So I think -g will be handy to find out where printf's functionality is defined externally, right? And that That is the assignment. So just tell me those who have not got what I asked you to do just now. Yes? Tell me. Am I connected?
Yes, sir. Yes.
So why are you silent? Why are you silent? Don't get tensed. You need some time, right? You need some study. These are not very tough things. These are conceptual things. Am I going a bit faster?
No,
Yes,
sir.
Basu?
No, sir. No, sir.
No, sir.
So
It's
did you
okay.
get, yeah, it's okay. So did you get the assignment? So let me write down the assignment. Basu, one more thing. Today when I logged into Miro, I found many of my boards to be is being owned by your friends from the last semester. So I cannot use those boards. Please ask them to release the ownership.
Oh, yes,
So
sir.
what? Yeah. So what you have to do is, just now we found that. See, I'm writing the question. Just now we found that we use the nm command. See, we use the nm command on testprogram.o to find out what are the symbols that are yet undefined. So we find exit to be undefined. So I remember last day I forgot to include stdlib.h, right? So see here, in spite of the fact that you have included stdlib.h, that is a static library, .h is always a static file. In spite of the fact that you have already included stdlib.h for this exit, still to exit to function properly, see, exit is a garbage collector sort of thing, right? So when it exists, it provides a code to the operating system. So exit will act in such a way such that it provides a code to the operating system when the program exits, so that using debugger or if some other system functionalities, you may find out what went wrong with the program, because when a program runs, it's a property of the system, right? So in spite of the fact that you included stdlib.h, still this symbol is undefined. That means your test program.o needs to be linked with other system-wide .o files that contains those exact functionalities that will help exit to put a code, exit code, that means an integer, to some specific register that the operating system knows that, okay, in this register the exit code of this program that is running is going to be set. Got my point? Similarly, printf, see, so you have included stdio.h. So you may ask me, sir, why printf is undefined? So printf, stdio.h has the function definition of printf, and that's why your program was compiled without any syntax error, because that stdio.h header file has all the definitions required for the compiler to understand and to parse what printf is. It understands that, okay, printf is a function, okay, this is how it is defined. The person who called printf from his testprogram.c file has not done any syntax error, he has not passed any garbage parameters, everything is okay, and it has compiled. But in order that printf works, how does printf work? It prints characters on your monitor, right? Your output device. Now what is that output device? In Linux, everything is a file. It's a file, it's called standard output file, stdout. Now that standard output file will talk with this printf function, right, using the operating system functionalities. So immediately it becomes an external thing, external to the test program.c that you compiled, and so test program.o. So in order that printf can use the display functionality, if printf can use the buffers that are required to push data so that it can be displayed to the operating system, then it is still undefined. It means that it is still looking for some system-wide objects to get the correct reference of some libraries such that it can run. Got my point? Yes or no?
Yes, sir.
Now remember testprogram.o. Now remember testprogram.o was the output from the assembler. Testprogram.o was output from your assembler. Assembler took testprogram.s and it outputted testprogram.o. Now the linker will link all these system-wide objects. Some .o, some .so, in fact some .sl. It can also link with some archives. It will link your testprogram.o with all these objects, system-wide objects. This is what I mean by system-wide objects. And after linking this, something will be born, and that is your executable test prog. And that is what you run, right? That is what you run. Test prog. Yes? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Sir, I had one
Yeah.
doubt.
Yeah, of course. I'm here to clear your doubts.
So what is? Can you go back to the command line once?
Okay, yeah. Who is speaking? Tell your name.
Sir, Praneeth.
Pranit. So this is the first time I hear from you, right?
Yeah.
Thank you.
Sir,
Yeah.
sir, what is the T beside main? I like
What?
that U that U means undefined. And what is the T?
Okay.
What does
So
the T mean?
yeah, I gave you an assignment, right? To go through the man pages of nm command. This answer you will be given by you. You have to give this answer. I was explaining what you means because I wanted you to understand why it is still undefined and what needs to be done more, right? And what needs to be done more?
The linking
Other
part.
system wide, yeah, the linking part, right? But all these details, not only T, what this 0000 signifies, you have to do a complete search on this command and tell me in the next day. I will not tell you right now because if I tell you, then the assignment has no value.
Sir, excuse
Yeah.
me.
Okay. Yeah. Who is called
Sir,
speaking?
Sir Arnav.
Yeah.
Sir,
See, what is T?
does the
What is
zero-
T? The symbol is in the text code section.
Yeah, sir.
See.
The 000 means, sir, I think from where the execution of the program starts.
Okay. Now, once you say that it's the point where the execution starts. Now, I have a next question that you need to answer. Now, is that point an absolute 000 address value, or it is relative to some address value?
So
Take down the
it
assignment.
must be relative. Okay, sir.
Yeah. So you have to explain. You have to explain me in the next day what their relativity is, with whom it is relative to. Yeah. Okay. So T means the text code section. I helped you right now, but you have to explain it to me. What exactly you mean by the text code section? Now I can give you another hint, of course. Now, yeah, a program has 3 sections, right? Yes, the text section, the code section, and the stack section. Do you remember all these things from the old semesters? Yes or no? Hello? Am I audible?
Yes, sir.
Yes, sir. Yes.
Yeah. Yeah. So when a program is loaded in memory, generally the virtual address space that is given to a program, it is generally at a very high level. It is of 3 parts: the code section, the text section, and what? The stack section, where the stack and the heaps are managed. Now, why the stacks and heaps are managed and need to be managed? Because that is how the local variables are stored when functions are called, right? Got it? Yes or no?
Yes, sir.
Yes, sir.
Okay. And U means the symbol is undefined. I put more stress on this so that the linking portion that I was talking about gets clear to you. Okay. Let me come back here. Okay. Now I will test prog.s. Okay. Now see, this is the .s file, right? The assembly file. So the main work of the compiler is, so I repeat it, the main work of the compiler is to take, what is happening? To take to take for example, we are talking about the C programming language, to take a .c file and generate code for your target architecture, right? This is the main portion of the compiler. Assemblers are not part of the compilers actually, right? But here in GCC we talk about the GCC is a complete package, right? So it tells that okay, I give you the compiler, I give you the assembler, and I give you the linker that works at tandem one by one, so that you get your executable file. So let us focus here, right? So ultimately the job of your compiler is to understand what is your .c file and generate code for your architecture. Now this .s is always dependent on your architecture. Agreed?
Yes, sir.
Now what is this? What does this arrow signify? Translation. Translation of this .c file to .s file. Right? Now since this is dependent on architecture, that is why I have given you so many documents to study in this class material section, and mainly I have given you the Intel Architecture Software Developers Manual Volume 2, Volume 1, a general assembly nomenclature document, and I have also given the Intel Architecture 32-bit special document. This is a special document, and you can see this document here. It's a system programming guide, right? So it gives you an overview of the architecture. It gives you an overview of memory management. Okay, we need to write a program on memory management, right? So that you get a good view of that. So it's a fantastic document to go through. Don't worry, keep a target that in this whole semester I will go through it, right? It's not that सर ने बोला है आज रात में ही पढ़ना चाहिए, एक रात में कुछ होता नहीं. This is a very good document. This is Introduction to 64-bit Intel Assembly Language Programming for Linux. So in the first class I was talking about a very closed system. This compilation system is a very closed system. It's a system software very closely associated with your architecture and your operating system, right? So these assembler directives are of course not dependent on your operating system. It is rather dependent on the architecture. So when I say that okay, I need to develop a compiler. So for example, I give you an assignment to develop a compiler for my x86 64-bit architecture for C. Additionally, I say that okay, for Linux. For example, when you go to GCC's website, you have download options GCC for Linux and GCC for Windows. Agreed? Yes or no?
Yes, sir.
But that operating system dependence has nothing to do with the .s structure. The .s structure is completely dependent on the architecture, right? All the mnemonics. Whether you write MOVL or you write MVLL, that all those things are architecture dependent. Okay? For example, you push an integer, incremented by the size of the integer. Let me put it in size of integer, and the memory resides here. Now you have an integer value, let it be 32 bits. Now is this the LSB and is this the MSB, least significant bit and most significant bit, or it is just the opposite?
So
It depends
This
on
is it depends on what? It depends on what?
Sir, big endian.
Yes, it depends on what?
Sir, big endian.
That is what it is called. I am asking, that depends on what? That depends on your architecture. Yeah, that depends on your architecture. You were answering me what it is called. I am not asking you what it is called, right? I am asking you that depends on the architecture. So you, when you are writing the assembler, when you are writing the compiler, you need to use only those directives, only those mnemonics that would take care of that also. Got my point? So now I have an idea. Write a program. Take this as an assignment to check the endianness of your architecture. I hope maximum people have the x86 architecture. Some has 64, some has 32. But these days, AMD Ryzen is also popular, right? How many of you have that AMD Ryzen? Write a program to check the endianness of your architecture. Very simple program, assignment. And after writing this program, what is happening with this Miro? Okay, after writing this program, compile with GCC save temps verbose -o endian checking echeck.c. You run this command and tell me you run this command to find some echeck.s file, right? Yes or no? You are going to get this file in your directory where you compile, and you go through the documents that I have supplied you for Intel. I'm sorry, I didn't supply any document for AMD. If you have at your home, please go through those. Please download. And so you get echeck.s, and then you comply with the documents that I have given you, and explain me in detail what are the fields of this echeck.s. You explain me in detail. What I mean is, so here you have this was your test program.s, right? So you take this as assignment number 1. You explain me what are these. For example, I give you hints. These are labels. Anything that starts with a character and ends with a colon are labels, right? And these are move q. Move q means, what does q mean? Any idea? What does L mean? Move L. Hello? L means long, right?
Yes,
Long
sir.
is, long is generally what? 32. Right?
Yes, sir.
So you have to explain what these test program.s mean. These are labels. How the labels are being addressed, how the labels are being reached. You have to explain me, right? And similarly, you have to write a program to check the Indianness of your own machine, and you generate your object file, and with the concept of your architecture documents that I have supplied you, you have to explain similarly what are the fields of echeck.s. Now, why I ask you to do this? I ask you to do this because the main compiler is, I repeat once more, the main compiler is, it takes a source code, this was the compiler, and it generates the target code, right? Target architecture code, that is the assembly. So if you don't understand what actually is generated, if you are unable to understand what actually is generated, you can never understand what the job of the compiler is. Because once you understand how this looks, how this works, then only you can define how you need to design your compiler such that you can convert a .c to this exact .s so that it works. So I am taking a reverse engineering approach. I am asking you to understand this .s and to have an idea what the compiler is supposed to do, such that you have an idea how to design a compiler. So I come back to those basic points. What a compiler is supposed to do. I mean exactly what it is supposed to do. It is supposed to build a .s file, done. But what exactly it is supposed to do, given a .c file as your source code. And once you understand that, so once you understand this, it is easier for you to understand this. And once you understand this, it is easier for you to understand point number 2, that is, once I understand what the compiler is supposed to do, how do I build a compiler such that it does what it is supposed to do. Make sense?
Yes, sir.
Yes or no?
Yes, sir.
Okay, so for that, are you in a mood to attend the class any longer? So for that translation from some .c to .s, what I can teach you is I can take single sample statements of .c file and show you conceptually. Why conceptually? Because I am not going to detail out the exact mnemonics as found in those manuals, right? I will just show you conceptually because that is my job. You have to find out what exact mnemonics are, what exact name of the registers. For example, you will find in Intel architecture register names named as %EBX, %EAX. These are the registers, right? If you can go here, you can find. See, these are registers. %RIP, %EAX. These are registers. But when I will be teaching you conceptually, I will just say that let there be a register called R1. Let there be a register called R2. Now, you have to find out that, okay, my Intel architecture exactly gives me 16 registers to work with. Got my point? You have to go through those manuals to find. But when I will teach, I will just conceptually talk about let the data be in some register R1. Okay? So that is how I can help you. So I can take single sample commands of .c file and show you conceptually what the .s should look like. Right? Happy? Yes or no? I can show you. For example, what to say? Let there is a variable I, and let we let us assume that I has been the value of that variable I has been kept in register R1. Done. Now there is a statement in your .c file. There is a statement in your .c file, and that statement is an assignment statement, I equal to 50. Right? So what should be the equivalent statement in your .s file? There is a statement I equal to 50, and let us assume that the value of I has been taken care of. It has been pulled from memory and taken in R1. By whom? By the system when the program is running, right? As a part of the fetch, execute, and what? Fetch, execute, and store.
Store, sir.
Right? This is the cycle that is going on for every instruction of your program. Fetch, execute, store, fetch, execute, store, fetch, execute, store. Right? 1 minute, I have a phone call. Hello? হ্যালো, এই শোন না ক্লাসে আছি আমি, একটু পরে করি। হ্যাঁ ঠিক আছে হ্যাঁ, ওকে বাই। Okay, my friend called me just now. So fetch, execute, store. So what I mean is, let that fetching has been done and the storing has also been done in R1, right? And in that cycle execution was not done. Now I want to for this I have to fetch I have to fetch the value of I have to assign value 50 to I. That is what I have to do, right? Now let us assume that I has been kept in R1. Why I talk about R1 and not directly memory? Because I am in a position to write the .s file, right?
Yes, sir.
Do you agree? So a simple command may be move 50 to R1. Agreed? Yes or no? So I equal to 50 in your .c file means should be translated to move 50 R1.
Yes, sir.
So this job of converting this to this should be done by your compiler. That means it has to access the register. It needs a privilege to access the register, and in your Intel it may be percentage EDX 50. It may be move L. This may be an exact of what your Intel architecture should be looking, and this is what as a teacher I am talking about conceptually. Got the difference? Yes or no?
Yes, sir.
Okay. So let me continue for 10 more minutes, right? So there is another. So this was example 1. Another example. Tell me some examples. Let there is an instruction called add I equal to j plus 20 in your .c. So the compiler has to convert this to equivalent .s. So it will be immediately add, right? Add is your mnemonic for your architecture. Let add is your mnemonic for your architecture. Then add the value. Okay, I was in R1, and so let j is in R2. Let j is in R2, right? So what I can do is add. What I can do is add
IU, sir.
Add R2, the value of register R2 to 50, because R2 contains J, right? Oh, sorry, to 20. 50 was the previous example. So 20, and store that in R1 because R1 contains I. Simple? Yes or no?
Yes, sir.
So your compiler has to do this. Okay? Okay? Yes or no? Now, let me talk about I++. Let there be an instruction I++. So what it needs to do? Add 1 to the value of I, right? Add I is in R1. I need to add 1 to the value that is in R1 and store back the value in R1. Right? So this was an example of execute and store, right? Okay. So what more example can I give? Hmm. Tell me some example that I can work with. Okay, there can be a very conceptual example since I'm talking about conceptual things. What is this? Let me test your concepts. What is this? In C?
Shift operator. Bitwise left shift.
Left shift operator, right? Left shift operator, right?
Yes.
Now
Yes.
let if
Yes, sir.
I and j are integers, let they be 32-bit integers, for example, and the value that I and j has, let it be restricted to the first byte only, a very small value. For example, i's value is 10 and j's value is 20, so that I have enough zeros to move left, right? Why I'm talking about that I should be having enough zeros when I move left, so that I do not create any accidental complexity of overhead or carry forward, right? Did you get my point? So even if I and j may be 32 bits long, well, let us think about okay, let me not complicate things. Let me take a small example. 2. So I equal to j2. What is this j2? So the compiler should try, yeah, left shift with 2 or 3. Left shift with 3. Okay. So what does it mean? It means that um, the compiler that sits here should try to find out some instruction like shift left. Maybe you have to find out what is the exact shift left for your Intel. Maybe some shift left logical, SLL, some SLL sort of thing. Shift left logical. This is logical, right? So J was in R2. So shift left logical R2 by 3 and then store the result in R1. So the job of the compiler is to find the appropriate translation. Now let me talk about another job of the compiler, that is optimization. Just give you a feel of that. Now what is I? Now what is I equal to j less than 3? I and j are small values, right? What it is actually? Left shift. Left shifting by 1 means multiplication by
2.
left shifting by 2 means multiplication by
2 to the power 2.
okay. Left shift by 3 means multiplication by
8.
8, right? So if your compiler is smart, he will try to always convert this left shift operator. He will try to find out a shift left logical sort of um, thing. And if your compiler is not smart, it will try to do something like I is equal to j star 8, right? So immediately when it does this, it means it is trying to have some multiplication j is in R2, right? R2 8 R1. This is the non-smart compiler, and this is the smart compiler. Shift logical is always much less costlier than multiplication. Agree or not?
Yes, sir.
Yes. So the compiler that translates this job to this sort of assembly .s is not that smart, but a compiler that does this to this sort of thing is a smart compiler. Now you may ask me that, sir, we can see logical left operator very clearly. Why are we becoming so complicated these days and thinking about this operation with multiplication? It is quite obvious that I have shift left operator, so I will call SSL. Now my answer will be that you are a human and you are seeing the whole thing together with your eyes on the board. Your machine doesn't see that. Your machine step by step will try to analyze this operation, and there is every chance when we go deeper in more classes, there is every chance that this left shift operator is converted to this code. I will explain you why. Because your machine doesn't see the whole thing that you are seeing in front of your machine, in front of your monitor. So the operator that looks like this gives you a very human feeling, right? Left arrow left में है, left shift है, 2 है, ठीक है, logical है. So J3, this means left shift. So why not I try to find out a shift LL, shift left logical sort of mnemonic. Who am I? I am the compiler. But this all depends, the interpretation of this all depends on how the compiler is designed. And I can show you that it can very well misjudge this statement, not misjudge, it can very well decode that statement to something like multiply J with 8. This is wrongly written by me. It should be multiply the register value where J is kept with 8, and so it should be multiply immediate, right? Because you are placing a value here. You are multiplying the register contents of R2 with some numeric value 8. There may be an instruction called multiply immediate, something like that, and then store the value in R1 if I is equal to J left shift 3, something like this. Done? So let us meet in next class. I will leave you today. Okay. So Basu, when is my next class? Yes. Basu, are you sleeping?
No, sir. I'm checking the class.
No, you are sleeping. I got you.
No, sir. I'm not
Sir,
sleeping. Monday, 5 p.m.
Monday at 5 p.m.
Yes, sir.
Okay. So we'll let us meet at Monday at 5 p.m. ठीक है? थोड़ा tired लग रहा है आज, हाँ?
Okay.
Because
sir.
it is so hot and humid. Okay. Any questions you have? How many people are there in my class? I never check for attendance. That is a blunder that I do.
44, 44 currently.
Okay, but I never accidentally hear from them. Okay. So let us meet on Monday, and assignment. I have given you 2 assignments, right? I want that those assignments to be done. So somebody will explain me how NM can be used to find out the references to libraries, though who contains those objects of printf, right? मैं भूला नहीं.
Yes, sir.
हाँ, मैं भूला नहीं मैं क्या बोला था. तो मंडे मुझे रिप्लाई चाहिए. ठीक है? Okay.
Yes.
Yeah. Have a good evening and enjoy your weekend.
Thank you.
Thank you, sir.
Yeah.
Thank you,
Thank you,
sir.
sir.
Yeah.